This research project, funded by Toka Tū Ake EQC and performed by Dr. Lucas Hogan from the University of Auckland, is looking at the seismic resilience of old concrete bridges, which we have across the Motu.
So I'm Lucas Hogan. I'm a senior lecturer in the Civil and Environmental Engineering Department at the University of Auckland, and the project that we have here is looking at the resilience of existing bridges on the New Zealand State Highway Network. With the testing that we're doing here, what we did is extract out existing bridge columns from a bridge that was being demolished. The bridge was about 85 years old, and it happened to be a really good representation of many other bridges on the State Highway Network. So we bring it into the lab and we put it on our strong floor and we push and pull on it to simulate an earthquake. And if we understand how this bridge behaves, it really gives us great insight into how similar bridges around the State Highway Network would behave, and really how resilient are they to an earthquake, and how likely are they to be able to function and get emergency services across, allow people and communities to recover quickly after an event. And I think one of the surprising things was just how well the bridge did, even despite the pretty significant amounts of corrosion damage that had suffered just from being out in the elements. The long-term goals of this work is to align with what our funders, EQC, Toka Tū Ake, and Quake Corps have, which is the enhancing seismic resilience of New Zealand. So the retrofit solution that we're looking on is, the idea is to try to contain the concrete. So as the bridge piers are moving back and forth, the concrete's pushing down and it wants to spall out. And so the idea is to provide some containment to that, just like you would the steel belts on a wine barrel.
Toka Tū Ake EQC funds projects like this to aid in our preparedness and recovery from natural hazard events.